Chapter 1. The Invisible Velocity. Right now, as you sit in the stillness of your room, you are moving at a speed that is fundamentally incompatible with the human nervous system. Your coffee sits undisturbed in its cup. Your breathing is slow and rhythmic, matching the heavy silence of the night. You feel a profound sense of solidity, the weight of your body against the chair, the unmoving walls, the floor that has never once shifted beneath your feet. But this stillness is a sensory illusion, a necessary deception provided by the scale of the world you inhabit. In the time it took you to hear that last sentence, you and everything you have ever known traveled roughly 60 meters through the dark. You are currently being hauled through a vacuum at 630 kilometers per second. That is 1.4 million miles per hour. If you were to travel at this speed on Earth, you could cross the Atlantic Ocean from London to New York in less than 9 seconds. You would circumnavigate the entire globe in under a minute. Yet, as you hurtle through the cosmic dark at this terrifying velocity, you feel absolutely nothing. This is the first great truth of our existence. We are passengers on a high-speed transit through an ocean of nothingness, and we are being pulled toward a destination we cannot see. To understand the scale of this motion, we have to look past the padded room of our atmosphere. We think of Earth as a stable home, but it is actually a small, rocky world tethered to a middle-aged yellow dwarf star. That star, our Sun, is orbiting the center of the Milky Way at 450,000 miles per hour. But the Milky Way itself is not stationary. Our entire galaxy, with its 400 billion suns, is falling through space. We are being dragged toward a specific point in the dark, a region of space hidden behind the thick dust of our own galactic disk, a place astronomers call the zone of avoidance. For decades, multiple independent teams of scientists have confirmed that our entire local neighborhood of galaxies is being reeled in like a fish on a line. We are moving toward a gravitational anomaly known as the Great Attractor. It is a mass so gargantuan that it defies standard orbital mechanics, a scaffolding of ghosts that exerts a tug across hundreds of millions of light years. But the data shows something even more unsettling. As we measured our velocity more precisely, we realized the Great Attractor isn't the final destination. We are moving past it, drawn by a deeper, more distant influence called the Shapley supercluster. And beyond even that, there is a region of almost perfect nothingness behind us, the dipole repeller, which is actively pushing us away. We are being simultaneously shoved by a void and hauled by a titan. This is confirmed science, published in peer-reviewed literature and measured directly by the motion of thousands of galaxy clusters. Yet even this does not explain the full extent of our velocity. There is an anomaly, a dark flow, where hundreds of galaxy clusters are moving in a coherent stream toward a point beyond our cosmic horizon. This suggests that the emptiness we see is merely a veil. It implies that somewhere, just out of sight, there are gargantuan structures so massive they are actively tugging on the fabric of our reality. You are inside this phenomenon right now. You are a participant in a cosmic drift across a wilderness so vast that the nearest stars are separated by distances that make our entire planet seem like less than a grain of dust. If the sun were the size of a single grain of sand on your kitchen table, the nearest star, Proxima Centauri, would be 19 miles away. Between those two grains of sand, there is nothing but light years of silent, protective nothing. This emptiness is not a flaw in the universe, it is a feature. It is the moat that protects your coffee cup from the nuclear fire of dying stars and the gravitational reach of black holes. We live in a Goldilocks era, a sweet spot in history, where the universe is empty enough to be peaceful, but full enough for us to exist and wonder why the silence is so absolute. The universe is empty for a reason. And as we begin to peel back the layers of that emptiness, the reason becomes increasingly terrifying. If this kind of deep investigation into the hidden mechanics of our reality interests you, subscribe now. The investigation into the great silence begins here. Chapter 2. The Backyard Illusion. When you step outside on a truly clear night, far from the orange hum of the city, your eyes suggest a universe of crowded abundance. The Milky Way stretches across the dome of the sky like a river of spilled milk, thick with light, seemingly packed with stars. It is beautiful, and it is almost entirely a lie. This is the backyard illusion. Everything you can see with your naked eye, every single point of light, every constellation, the soft glow of the galactic disk, is contained within a tiny, immediate cosmic neighborhood. The farthest stars you can perceive without a telescope are roughly 15,000 light-years away. To a human mind, 15,000 light-years sounds like an eternity. But we have measured the scale of our home. The Milky Way galaxy is at least 100,000 light-years across. The data shows that when you look up at that full night sky, you are seeing less than 15% of your own galaxy. You are standing in the cosmic equivalent of your backyard and assuming that because you see grass and a few trees, the entire Earth must be a garden. You are unaware of the vast frozen deserts, the empty oceans, and the silent mountain ranges that lie beyond the fence. This is established science, confirmed by decades of mapping and direct observation. To bridge the gap between what you see and what is actually there, we need to move away from light years and into something you can touch. We need a domestic scale. Imagine the Sun, the massive star that anchors our solar system, is scaled down to the size of a single grain of sand. It is exactly 1 millimeter in diameter, sitting on your kitchen table. At this scale, the Earth is an invisible speck of dust orbiting less than 4 inches away. Our entire solar system, out to the furthest icy reaches of the Oort cloud, fits comfortably within the walls of your house. Now, look out your window. You want to find the next nearest grain of sand, the next star, Proxima Centauri. To find it, you would have to leave your house and begin walking. You would have to walk past your neighbor's home, past the edge of your town, and across the countryside. You would have to walk for 19 miles. Between the grain of sand on your table and the 119 miles away, there is nothing. No other stars, no other planets, just 19 miles of silent, empty air. This is the typical spacing within the crowded arms of our galaxy. If you wanted to find the Andromeda galaxy, our nearest large neighbor, on this same scale, you would have to place a grain of sand roughly 11,000 miles away. That is like standing in London and trying to see a single grain of sand on a beach in Australia. This is the reality the data reveals. The universe is not a crowded ballroom of light. It is a planetary graveyard, punctuated by occasional, lonely sparks. The question that naturally arises from this scale is what fills that 19-mile gap. We often use the word vacuum to describe the space between stars, but that implies a perfect absence that doesn't quite exist in nature. Astronomers have measured the material between these grains of sand, a substance called the interstellar medium. It is remarkably sparse. Consider the air you are breathing right now. In every cubic centimeter of air around your face, there are approximately 25 billion molecules. It is a dense protective soup that carries sound and sustains your life. Now, move into the interstellar medium, the space between those grains of sand. In that same cubic centimeter of space, you would find perhaps 1 or 2 atoms. This is not just empty, it is a level of nothingness that we cannot replicate even in our most advanced laboratories. On Earth, scientists build massive vacuum chambers to test satellites, using powerful pumps to remove as much air as possible to simulate the conditions of space. Yet even those chambers, the emptiest places on our planet, are crowded and noisy compared to the true void between the stars. This is not speculation. This is measured reality. If you were to board a spacecraft and attempt to cross this void, the isolation would be absolute. Light, the fastest thing in existence, travels at 670 million miles per hour. It is the cosmic speed limit. Even at that impossible velocity, a beam of light takes over 4 years to cross the gap from our Sun to its closest neighbor. If you were to attempt this journey in a car driving at highway speeds without ever stopping, it would take you 50 million years to reach the nearest star. 50 million years of driving through a darkness so complete that for the vast majority of your journey, your headlights would illuminate absolutely nothing. Some people find this isolation terrifying. They imagine themselves lost in that 50 million year darkness, a tiny spark of life floating helpless in an ocean of nothing. They feel the weight of their own insignificance against a scale that makes our entire planet seem like less than a grain of dust. But there is a different way to look at this emptiness. It is a perspective that changes the terrifying into something profoundly comforting. The emptiness of the universe is not a prison, it is a moat. It is the most perfect protection ever devised. That 25 trillion miles of nothingness between us and the nearest star is the reason you are safe. It is the buffer zone that allows life to grow slowly, patiently, over billions of years without being extinguished by the chaos of the broader cosmos. Somewhere out there, right now, a star is dying. It is collapsing under its own weight and exploding in a supernova, an event so violent it outshines an entire galaxy of 400 billion stars. If you were standing on a planet anywhere near that explosion, you would be vaporized in a fraction of a second. But you are not close. You are here on this small, rocky world, protected by light years of beautiful, silent nothing. The emptiness absorbs the violence. The void dampens the noise. We live in a quiet neighborhood. Our sun is a middle-aged yellow dwarf, sitting in a suburban stretch of the Milky Way, where stars are spaced comfortably apart. We are not in the crowded, dangerous downtown of the galactic center, where stars are packed together and radiation levels are lethal. We are tucked away in a corner where the universe essentially leaves us alone. This location is not an accident of design, but a consequence of our existence. This is a form of selection bias known as the anthropic principle. We observe the universe to be this empty because, if it were any fuller, we wouldn't be here to observe it. If stars were packed like traffic in a city, Earth's orbit would be disrupted every few thousand years. Our atmosphere would be stripped by the radiation of nearby neighbors. Life would never have been given the 4 billion years of peace it required to evolve from simple chemistry into the consciousness you are using to process these words. We are the children of the void. We exist because the universe is so gloriously, peacefully empty. But as we look deeper past our local backyard and into the structures that hold the galaxies themselves, we find that this neighborhood is just the beginning of the void. The emptiness we have described so far, the 19 miles between grains of sand, is actually the crowded part of the universe. When we point our telescopes past our own stars and into the space between galaxies, the scale of the nothing escalates in a way that truly does defy human comprehension. We move from a backyard into a wilderness where even the galaxies themselves are just tiny islands of matter lost in a sea of expanding vacuum. And it is here, in the great gaps between the islands, that we discovered the first real complication. Because when we finally measured how much matter was in the universe, we realized that the nothing we were looking at wasn't actually empty at all. The investigation continues with the moment we realized we were missing 95% of reality. If you find this scale of investigation satisfying, ensure you are subscribed. The discovery of what hides in the dark is next. Chapter 3. The Hubble Revelation. You have spent your entire life assuming that if you look at a dark corner of the night sky, you are looking at nothing. But the data shows that your eyes are being tricked by the limits of human biology and the immense distance that light must travel to reach you. For most of human history, we believed the gaps between the stars were exactly what they appeared to be. A vacant stage, a hollow backdrop for the few sparks of matter that managed to ignite. We looked at the blackness between the constellations and saw a wall of silence. In 1995, a small team of astronomers decided to test that silence. They decided to gamble the most expensive piece of scientific equipment ever built on the possibility that the nothing was a lie. At the time, the Hubble Space Telescope was still recovering from its own troubled beginning. It had been launched with a flawed mirror, a blurred vision that had made it a laughingstock in the media. Though it had been fixed, the pressure to produce undeniable, groundbreaking results was immense. The telescope's time was the most precious commodity in the scientific world, passed out in seconds to researchers who had spent years justifying their proposals. To point this multi-billion-dollar instrument at a patch of sky where there was absolutely nothing to see was considered by many to be a career-ending waste of resources. But Robert Williams, the director of the Space Telescope Science Institute, decided to use his director's discretionary time to do exactly that. He chose a tiny, unremarkable patch of sky in the constellation Ursa Major. This was a region that looked completely and utterly vacant. There were no nearby stars to interfere with the light. There were no known gas clouds. It was a window into the absolute dark. To understand how small this window was, you need to look at your own hand. Imagine you are holding a single grain of sand between your thumb and forefinger. Now, extend your arm fully toward the night sky. The tiny speck of that grain of sand, held at arm's length, covers the exact amount of space that Hubble was about to investigate. It was a region so small that it would take 12 million such patches to cover the entire sky. For 10 consecutive days from December 18th to December 28th, Hubble stared. It did not move. It did not blink. It simply sat in the silent vacuum of Earth's orbit, its sensors open, waiting for the arrival of photons that had been traveling through the void for billions of years. This is the discovery phase, the moment when our understanding of the scale of the universe shifted forever. Hubble gathered light for 100 hours of total exposure time. It wasn't a single snapshot. It was a slow, patient accumulation of energy. One photon would strike the sensor, then another, then a long silence, then a third. The telescope was drinking from a trickle of light so faint that it was essentially invisible to any other instrument in existence. When the data was finally processed and the image, the Hubble Deep Field, was revealed, the silence was broken. The nothing was gone. In that tiny, grain of sand-sized patch of darkness, where we expected to find a few stray atoms or perhaps a single dim star, Hubble found approximately 3,000 galaxies. This is confirmed science. This is not a simulation or a mathematical estimate. It is a direct measurement of reality. Every single blob of light in that image, every smudge, every spiral, every glowing dot was an entire galaxy. Some were similar to our Milky Way, elegant spirals of blue and gold. Others were massive, featureless elliptical clouds. Some were distorted, caught in the middle of violent collisions that had lasted hundreds of millions of years. And each one of those 3,000 galaxies contained hundreds of billions of stars. Think about the scale of that revelation. In a patch of sky so small you could hide it with a grain of sand, there were more stars than there are people on Earth. There were more planets in that tiny window than there are grains of sand on every beach in the world. And this wasn't a special region of space. We have since repeated this experiment in other, empty patches of sky, including the Hubble Ultra Deep Field and the Extreme Deep Field. The result is always the same. Everywhere we look, in every direction, the universe is packed with galaxies. Based on this data, multiple independent teams of scientists have confirmed that there are approximately 2 trillion galaxies in the observable universe. To put that number in its own space, 2 trillion. If you take that average of 100 billion stars per galaxy and multiply it by 2 trillion galaxies, you arrive at a number that the human brain simply cannot process. 200 billion trillion stars. That is a 2 followed by 23 zeros. This is the moment of intellectual satisfaction, the feeling that we finally understand the sheer abundance of the cosmos. It suggests a universe that is crowded, vibrant, and overflowing with matter. It creates a sense of cosmic fullness. If there are 2 trillion galaxies out there, then the night sky shouldn't be black. It should be a solid wall of light, a blinding mosaic of suns. This is what astronomers call Fermi Paradox. If the universe is infinite and full of stars, why is the night sky dark? The answer to that question brings us to the first great complication of our investigation. While the Hubble Deep Field showed us that the universe is full of things, it simultaneously revealed how far apart those things actually are. As we began to map these 2 trillion galaxies in 3 dimensions, we realized that the nothing wasn't just a lack of stars, it was the dominant structure of reality. We discovered that galaxies aren't scattered randomly like dust. They are arranged in thin, fragile filaments like the strands of a spider web. They gather in clusters where the threads of the web intersect. But between those threads there is a wilderness that makes the 19-mile gap between our local stars look like a crowded room. Astronomers began to measure the distance between these galaxy clusters and found regions of space called voids. These are bubbles of almost pure vacuum, some stretching across 300 million light-years. To put that distance into a human analogy, if our galaxy were a single grain of sand, the nearest major cluster of galaxies would be a football field away. And between those 2 grains of sand there is nothing. No stars, no gas, no light, just 100 yards of silent, absolute void. This is the complication. Everywhere we look, there is something, but that something is so vanishingly rare that it constitutes almost 0% of the universe. We have measured the total volume of all those 200 billion trillion stars. We have calculated the total volume of the observable universe, a sphere 93 billion light-years in diameter. When you divide the volume of the stars by the volume of the space they inhabit, you find that matter is not the rule of the universe, it is the exception. The data shows that stars occupy less than 1/quadrillionth of 1/quadrillionth of 1/quadrillionth of a percent of space. This is the first great truth we must reconcile. The Hubble Deep Field gave us a vision of a crowded universe, but the math gives us a vision of a hollow one. We are living in a cosmic ocean where the water, the matter, is so sparse that you could travel for billions of years at the speed of light and never hit anything at all. We have confirmed that the galaxies are there, billions of them tucked into every corner of the sky. But we have also confirmed that they are drifting in a darkness so vast that the word empty fails to describe it. And as we looked closer at those 3,000 galaxies in that tiny grain of sand, we noticed something even more unsettling. The galaxies were moving. They weren't just drifting, they were being hauled away. The space between them was growing. The revelation of Hubble wasn't just that the universe is full of galaxies, but that the universe is actively, aggressively trying to separate them. The investigation is ongoing, and we are the species doing the measuring. We have found the matter, but now we have to ask why it is spread so thin. Why is the nothing winning? The investigation into the quadrillionth of a percent begins in the next chapter, where we will shrink the entire universe down to the size of the Earth to see what actually remains. If this level of numerical precision and the search for the hidden structures of reality interests you, ensure you are subscribed. The discovery of the true scale of the void is next. Chapter 4. The quadrillionth of a percent. The Hubble deep field gave us a vision of a universe that is crowded, vibrant, and overflowing with light. It offered us 2 trillion galaxies, each one a swarming hive of hundreds of billions of suns. To a human mind, this feels like abundance. It suggests that if you were to travel through the cosmos, you would be constantly surrounded by the heat and matter of distant worlds. But this is the point where the data forces us to confront a much more unsettling reality. When we take those numbers and apply the cold, objective precision of mathematics, the illusion of a full universe evaporates completely. This is the complication. The more we find, the more we realize how little of it there actually is. Let's perform the math. This is not speculation. It is a calculation based on direct observations from the Hubble Space Telescope and the Planck satellite. First, consider the stars. We have measured the average number of galaxies in the observable universe to be approximately 2 trillion. Each of these galaxies, on average, contains 100 billion stars. When you multiply these two figures, you arrive at a number that serves as the total population of suns in our sky, 200 billion trillion stars. That is a 2 followed by 23 zeros, 200,000 billion stars. To a person standing on a beach, this number is often compared to the grains of sand on Earth. It is a useful analogy for count, but it fails to capture the terrifying truth of volume. To understand that, we have to look at how much physical space those 200 billion trillion stars actually take up. We take a typical star, like our own Sun, which has a diameter of about 864,000 miles. Using the standard formula for the volume of a sphere, we can calculate that our Sun occupies approximately 1.4 billion cubic miles. Now we take that volume and multiply it by every single one of those 200 billion trillion stars in the observable universe. We arrive at the total volume occupied by all the matter, every glowing sun, every planet, every moon, and every asteroid in existence. That number is approximately 2.8 times 10 to the 32nd power cubic miles. It sounds enormous. It sounds like a volume that would surely fill a significant fraction of reality, but now we have to measure it against the container it sits in. The observable universe is a sphere with a radius of approximately 46.5 billion light-years. When you convert that distance into miles and calculate the volume of that sphere, you arrive at a figure that is almost impossible to write out: 3.6 times 10 to the 80 power cubic miles. Now we perform the final division. We divide the volume of all the stars by the total volume of the universe. The data shows that stars occupy less than 1 quadrillionth of 1 quadrillionth of 1 quadrillionth of a percent of space. Let that number sit with you for a moment. It is 0.0000 with 48 zeros, followed by a 7. This is the confirmed density of our reality. It means that for every 1 part of something in the universe, there are roughly 10 to the 49th power parts of absolute, silent nothing. If the universe were a lottery and you were looking for a piece of matter, your odds of finding a single atom would be so low that the word impossible becomes a statistical understatement. But numbers of this magnitude are often where the brain checks out. To make this landing, we must move away from the quadrillionths and into a human-scale analogy you can visualize. Imagine we take the entire observable universe, all 93 billion light-years of it, and we shrink it down until it is exactly the size of the Earth. In this scaled-down reality, the Earth-sized universe is your field of play. Now imagine you are searching for all the matter that exists in that universe, You gather every star from every one of those 2 trillion galaxies. You gather the 200 billion trillion suns, all the planets, all the nebulae, and all the dust. You crush them together into a single, solid ball of matter. In an Earth-sized universe, all of that matter combined would be smaller than a single atom. Actually, the measurement is even more extreme than that. If the universe were the size of the Earth, all the stars in existence would occupy a volume smaller than a single proton. This is what the data reveals. You are living in a reality that is, for all practical purposes, entirely hollow. If you were to teleport to a random location in the universe, you would find yourself in a darkness so absolute that the nearest atom might be light years away. You would be a lone spark of complexity in an ocean of void that is trillions of times larger than any structure it contains. But there is a deeper complication, a law gap that most people never consider. This terrifying emptiness is not just something that exists out there between the galaxies. It is not a distant problem of cosmic geography. This emptiness is currently inside you. The data shows that the same ratio of something to nothing that governs the stars also governs the atoms in your own body. Just as the universe is a quadrillionth of a percent matter, an atom is a quadrillionth of a percent solid. Look at your hand right now. You feel the weight of it. You feel the solidity of the skin and the bone. But this is a sensory deception provided by the electromagnetic force. If you were to remove all the empty space from the atoms in your body, you would be so small that you would be invisible to any microscope on Earth. You would be a microscopic speck of stuff, lost in a body of nothing. If you shrank the atoms of your body to the scale where the nucleus was the size of a peanut, the electrons would be orbiting miles away. Everything in between, the solid part of your hand, is actually a vacuum as empty as the space between the Milky Way and Andromeda. This is the hollow body correlation. The terrifying emptiness of the universe is not a distant threat. It is your fundamental state of being. You are not a solid object moving through an empty universe. You are a collection of empty spaces moving through a larger empty space. Solidity is merely the name we give to the way our nerves interpret the repulsion of invisible forces. This realization changes the meaning of the word matter. We used to think of the universe as a container filled with things, but the math shows us that the universe is a void that is occasionally, and very rarely, interrupted by the presence of things. We are the anomaly. We are the defect in a perfect system of nothingness. And yet even this measurement, the quadrillionth of a percent, turns out to be incomplete. Because as we began to measure the way those lonely galaxies were moving, we realized that the nothing wasn't actually empty. It couldn't be. If the universe were as empty as the visible light suggests, the galaxies themselves would not be able to hold together. They would fly apart like steam in a wind tunnel. There had to be something else, something heavy, something invisible. The investigation into the nothing revealed that we were missing 95% of the story. We discovered that we are living in a house made of invisible materials, and we have only just begun to see the shadows they cast. If this kind of deep, numerical investigation into the true nature of your reality interests you, ensure you are subscribed. The investigation into the scaffolding of ghosts, the invisible 95%, is next. Chapter 5. The Scaffolding of Ghosts. The universe is empty, but the data suggests that this emptiness is a physical weight you simply haven't learned to feel yet. We have calculated the volume of the stars and found them to be a quadrillionth of a percent of reality. We have shrunk the cosmos to the size of the Earth and found that everything we can see would fit inside a single proton. But as we began to measure how these lonely islands of matter actually behave, we ran into a wall of mathematical impossibility. The galaxies are moving in ways they shouldn't. They are staying together when they should be flying apart. And the reason for this is the most significant discovery in the history of modern cosmology. The realization that you are living in a house made of invisible materials. This is the missing mass problem. It is not a theory or a suggestion. It is a direct measurement of a gravitational anomaly that has been confirmed by multiple independent teams of scientists over the last 90 years. The investigation began in 1933 with a man named Fritz Zwicky. He was a Swiss astronomer studying the Coma cluster, a massive gathering of over 1,000 galaxies located roughly 320 million light-years away. Zwicky was performing a relatively straightforward calculation. He measured the velocity of the galaxies as they orbited the cluster's common center of mass. In physics, there is a fundamental relationship between speed and gravity. If you want to keep a group of objects together, you need enough mass to generate the gravitational pull required to hold them. If the objects move too fast, the gravity won't be strong enough to tether them, and the group will dissolve. Zwicky counted the galaxies. He measured their brightness. He estimated their mass based on the light they emitted. Then he looked at the speed. The galaxies in the Coma cluster were screaming through the void. They were moving so fast that based on the visible matter Zwicky could see, the cluster should have evaporated billions of years ago. The galaxies should have been flung out into intergalactic space like mud off a spinning tire. Zwicky performed the math and found a discrepancy that defied logic. To generate enough gravity to hold those galaxies in place, the cluster needed 400 times more mass than he could actually see. There was a scaffolding of ghosts holding the cluster together, a massive, invisible presence that exerted a tug but refused to show itself to a telescope. He called it dunkle materia, dark matter. At the time, the scientific community ignored him. They assumed he had made a mistake in his measurements. They assumed the missing mass was just dust or dim stars we hadn't found yet. But 40 years later, the data returned, and this time it was undeniable. In the 1970s, astronomer Vera Rubin began studying the rotation of spiral galaxies. She was looking at the galaxy rotation curve. To understand this technical term in plain English, think of a carousel. If you are standing near the center of a spinning carousel, you move relatively slowly. If you move to the very outer edge, you feel the wind whip past your face as you move much faster. However, the solar system works the opposite way. Because the Sun contains 99% of the mass, its gravity is strongest at the center. Therefore, Mercury orbits the Sun at 100,000 miles per hour, while Neptune, far out in the weak gravity of the suburbs, limps along at only 12,000 miles per hour. Gravity weakens with distance. This is an unbreakable rule of orbital mechanics. Rubin expected to see the same thing in galaxies. She expected the stars at the outer edges of a galaxy to move much slower than the stars near the center. But that is not what she measured. The data showed that stars at the extreme edges of galaxies were moving just as fast as the stars near the core. In some cases, they were moving even faster. This made no sense. If the only mass in the galaxy was the light-emitting stars and gas we could see, those outer stars should have been flung into the void long ago. The only way they could stay in orbit at those impossible speeds was if the galaxy was far heavier than it looked. Rubin's observations confirmed that for every kilogram of normal matter, the protons, neutrons, and electrons that make up your body and the stars, there are approximately 6 kilograms of something else. This is where the terrifying nature of the emptiness takes on a new layer. We have confirmed through gravitational lensing, a technique that measures how gravity bends light, that this invisible mass isn't just a few stray rocks, it is a fundamental part of the architecture of the universe. We now call this substance dark matter, but a more accurate name would be the scaffolding. In the early universe, just after the Big Bang, the normal matter we are made of was a hot, chaotic mess. It interacted with radiation. It felt pressure. As gas tried to clump together to form the first stars, the heat and radiation pushed back, preventing the gas from collapsing. Normal matter was too noisy to build anything on its own. But dark matter is silent. It does not emit light. It does not absorb light. It does not feel radiation pressure. Because it was immune to the push of the early universe's heat, dark matter was able to collapse freely under its own gravity. It clumped together first, forming what astronomers call dark matter halos. To translate this into a domestic analogy, imagine you are watching a house being built, but the steel frame is invisible. You see the drywall and the bricks suddenly fly into the air and arrange themselves into the shape of a room. To an outside observer, the bricks are floating in a way that defies gravity. But the reality is that the bricks are merely clinging to a steel structure that you cannot perceive. The data shows that every galaxy in the universe, including our own Milky Way, sits at the center of a massive dark matter halo. The visible galaxy, the part with the stars and the planets and your coffee cup, is only the drywall. The real structure, the scaffolding that allows the galaxy to exist, is a sphere of invisible mass that is 6 times larger than the visible disk. If you were to remove the dark matter from the Milky Way right now, the galaxy would cease to exist. The stars would lose their tether. The spiral arms would unwind. The gravity of the visible stars is simply not strong enough to hold the system together. We exist because we are sheltered within a gravitational well created by a ghost. But this revelation brings us to the deeper complication, the realization of our own insignificance within the total mass-energy budget of the universe. For centuries, we assumed that matter meant the things we could see. We thought we were the main characters of the cosmic story. But the Planck satellite and the Dark Energy Survey have measured the totals, and the results are humbling. This is what the data says. Normal matter, everything you have ever touched, every star Hubble has ever photographed, every atom in every person who has ever lived, makes up only 5% of the universe. 5%. That is the anomaly. We are the spare change in the pocket of the cosmos. 27% of the universe is dark matter. The remaining 68% is something even more mysterious, a force called dark energy, that we will investigate shortly. This means that 95% of reality is made of materials that do not interact with you in any way except through the silent pull of gravity. You are currently inside this phenomenon. Right now, as you sit there, billions of dark matter particles are flowing through your body, through your house, and through the Earth itself. They are passing through you as if you are the ghost. You don't feel them because they don't interact electromagnetically. They do not bump into your atoms. We are living in an invisible mansion, and we have spent our entire history admiring the dust motes dancing in a single shaft of light, completely unaware of the massive, silent walls that surround us. This is confirmed science published in peer-reviewed literature and measured across multiple scales of the cosmos. We know the scaffolding is there because we can see the galaxies clinging to it. We know the ghosts are real because we can measure the weight of their shadows. But as we looked closer at this scaffolding, we noticed something even more disturbing. The scaffolding isn't just holding us up, it is being stretched. The nothing between the galaxies is growing, and it is growing at a rate that suggests the universe isn't just empty, it is being actively emptied. The investigation is ongoing, and we are the species doing the measuring. But the more we measure, the more we realize that the 5% of something we inhabit is being steadily outpaced by the 95% of nothing that wants to tear it apart. The investigation into the Great Erasure, the force that is actively destroying the cosmic web, begins in the next chapter. If you find this level of technical precision and the discovery of our place in the invisible 95% satisfying, ensure you are subscribed. The investigation into dark energy and the final fate of the void is next. Chapter 6. The Great Erasure. Right now, as you watch this, the universe is being dismantled. It isn't happening with the violence of an explosion or the grinding of gears. It is happening in the silence between your atoms and the gaps between the stars. You cannot feel it, and your senses are not equipped to detect it, but the very fabric of the reality you inhabit is being stretched so thin that entire sections of the cosmos are winking out of existence forever. For most of the 20th century, we believed we understood the fate of the universe. We knew the Big Bang had set everything in motion, and we knew that gravity, the great attractor, was the primary force of the cosmos. We assumed that because matter has mass and mass creates gravity, the expansion of the universe must be slowing down. Like a ball thrown into the air, we expected the upward momentum of the Big Bang to eventually lose its fight against the downward pull of gravity. The only question among scientists was whether the ball would eventually fall back down in a big crunch, or if it would simply drift to a slow, frozen stop. But in 1998, the data destroyed that assumption. Two independent teams of astronomers, the High-Z Supernova Search Team and the Supernova Cosmology Project, set out to measure this deceleration. They were looking for Type 1a supernova, which are the most reliable standard candles in the universe. These explosions occur when a white dwarf star, a dense remnant of a dead sun, pulls so much matter from a companion star that it reaches a critical mass of exactly 1.4 solar masses. Because they always explode at this exact mass, they always produce the same amount of light. By measuring how dim these explosions appeared from Earth, the teams could calculate exactly how far away they were. What they found was not a slowing down, it was an acceleration. The distant supernovae were fainter than they should have been. They were further away than gravity should have allowed. This is confirmed science, measured directly and published in peer-reviewed literature. The expansion of the universe is not slowing, it is speeding up. Something in the void is pushing back against gravity, and it is winning. We call this force dark energy, though that name is merely a label for our ignorance. We have no idea what it is, but we can measure what it does. Dark energy appears to be a property of space itself. In the world of our everyday experience, we think of space as an empty box, a passive stage where things happen. But the data shows that space is not passive. Space is a thing. It has a ground state energy, a vacuum energy, that exerts a repulsive pressure on everything within it. This is the deeper complication. The more space there is, the more push there is. Imagine a cubic meter of empty space. According to quantum field theory, that cubic meter is not empty. It is seething with virtual particles and energy. That energy is very small, roughly 10 to the power of -9 joules per cubic meter, but it is constant. When the universe expands and a cubic meter of space becomes 2, the energy does not dilute like matter or radiation. Instead, you now have 2 cubic meters of space, which means you have twice as much energy. This creates a terrifying feedback loop. Expansion creates more space creates more dark energy. More dark energy causes faster expansion, which in turn creates more space. The acceleration compounds over time. We are living in a runaway universe where the void is actively, aggressively manufacturing the very force that is tearing the cosmos apart. Dark energy now makes up approximately 68% of everything in the universe. Normal matter, the stars, the planets, and your own body, makes up less than 5%. We are a tiny, fragile minority living in a reality dominated by an invisible force that wants to push everything away from everything else. The consequence of this acceleration is the creation of the cosmic event horizon. This is the point where the distance between us and a distant galaxy becomes so great, and the expansion of space becomes so fast, that the galaxy begins to recede from us faster than the speed of light. This does not violate Einstein's laws of physics, because the galaxy isn't moving through space faster than light. The space between us is simply stretching. Think of it like a swimmer trying to head upstream in a river. If you are a photon of light leaving a distant galaxy and heading toward Earth, you are swimming through space at 300,000 kilometers per second. But if the space you are swimming through is expanding backward at 400,000 kilometers per second, you will never arrive. You are making forward progress through the water, but the river is carrying you away faster than you can swim. Based on current measurements, any galaxy further than roughly 14 to 16 billion light-years away is already receding from us faster than light. This defines the edge of our observable reality. Objects beyond this horizon are forever beyond our reach. We can never visit them, we can never send them a message, and we can never receive their light. They are, for all practical purposes, gone. The most unsettling part of this data is that the horizon is moving inward. As the expansion of space accelerates, more and more galaxies are being swept across this invisible line. This is the Great Erasure. Right now, at this exact moment, galaxies are crossing the event horizon and vanishing from our future forever. Scientists estimate that approximately 60,000 galaxies cross this horizon every single year. That is 160 galaxies per day. Nearly 7 galaxies have vanished in the time it has taken you to watch this chapter. We are living in a shrinking window of cosmic history. Trillions of years from now, the expansion will have carried every single galaxy, except those in our immediate local group, beyond the horizon. Our descendants will look up at a sky that is almost entirely empty. They will see only the merged remains of the Milky Way and Andromeda. To them, the universe will seem static, small, and lonely. They will have no way of knowing that billions of other galaxies ever existed. They will be unable to see the afterglow of the Big Bang, as that light too will have been redshifted into total invisibility. We are the last generation of observers who can still see the whole picture. We are the witnesses to a universe that is being systematically redacted. But there is a complication that physicists find even more disturbing than the erasure itself. When we use quantum mechanics to calculate how much energy should be in the vacuum of space, we get a number. When we use our telescopes to measure how much energy is actually there, we get a different number. The theoretical prediction and the measured reality differ by 120 orders of magnitude. This is often called the worst prediction in the history of physics. It means that something is fundamentally broken in our understanding of how the nothing works. Either our theories of the very small, quantum mechanics, are wrong, or our theories of the very large, general relativity, are incomplete. We are standing in a house where the walls are moving, and we don't even know what the walls are made of. We only know that they are pushing us toward a final, absolute isolation. This is the invisible nature of our reality. The universe is not just empty, it is actively trying to become emptier. It is erasing its own history, one galaxy at a time, until only the silence remains. If you find this level of deep investigation into the hidden mechanics of our reality satisfying, ensure you are subscribed. The investigation continues in the next chapter, where we will enter the most isolated regions of all, the cosmic voids, to see what it's like to live inside the Great Nothing. Chapter 7. The Geography of the Void. Right now, as you look toward the constellation of Boötes, you are staring into the largest wound in the known universe. To your eyes, it looks like any other dark patch of the night sky, a silent, unremarkable curtain of blackness. But the data shows that this specific region of space is fundamentally different from the crowded wilderness we have explored so far. While we have established that the universe is overwhelmingly empty, the Boötes void represents a level of nothing that contradicts our basic models of how the cosmos is structured. This is what astronomers call the Great Nothing. It is a spherical chasm in the fabric of reality that spans roughly 330 million light-years in diameter. To understand that scale through a domestic analogy, imagine the Milky Way. Our entire galaxy, with its 400 billion stars, is a single grain of sand. To cross the Boötes void, you would need to line up 150 of those grains of sand side by side. In any other part of the universe, a volume of space this large should be a vibrant metropolis of activity. Based on the average density of the cosmic web, a region this size should contain at least 10,000 galaxies. In 1981, when astronomer Robert Kirshner and his team first pointed their telescopes at this region, they expected to find exactly that, a rich, interconnected map of thousands of glowing islands. They expected to see the standard filaments and sheets of the cosmic web. But the measured reality was unsettling. Instead of 10,000 galaxies, they found approximately 60. This is a vacancy rate of 99.4%. This is not speculation. It is a direct measurement confirmed by multiple independent surveys, including the Sloan Digital Sky Survey and the 2DF Galaxy Redshift Survey. The Boötes void is a hole in the universe so large and so empty that it shouldn't have had enough time to form since the Big Bang. Under the standard laws of gravity, matter moves slowly. It takes billions of years for galaxies to drift out of a region to create a void. The sheer scale of Boötes suggests that something, perhaps a variation in the strength of dark energy itself, is hollowing out the universe faster than our physics can explain. To feel the weight of this emptiness, you have to place yourself inside it. Imagine you are an observer living on a planet in the exact center of the Boötes void. If you were to look up at your night sky, you would see a darkness so absolute it would be psychologically crushing. In our current location on the edge of the local sheet, we can see thousands of stars with the naked eye and millions of galaxies with a basic telescope. But from the center of the Great Nothing, your sky would be a featureless vault of black. The nearest neighboring galaxy would be so far away that it would be invisible to the naked eye. It would be 165 million light-years to the nearest significant light source. For an observer in Boötes, the backyard illusion we discussed earlier would be even more extreme. You would look out into the 330 million light-years of nothingness and conclude with absolute certainty that you were the only thing in existence. You would have no evidence of the 2 trillion other galaxies that populate the rest of the universe. You would live in a quiet room where the cosmic noise has been turned all the way down, unaware that you are merely an anomaly in a much larger, more crowded story. But the Boötes void is not a distant, isolated curiosity. It is a part of the geography of the void that directly influences the room you are sitting in right now. Multiple independent teams of scientists have confirmed that we are currently being influenced by a similar structure known as the local void. This is a region of underdense space approximately 150 million light-years away. While it is not as large as Boötes, it is close enough to act as a repeller. To understand this, you have to look at the data on how galaxies move. Gravity pulls matter together, which means dense regions like the Great Attractor pull on us. but the voids exert an apparent repulsion. Because the void is empty, it has no gravitational pull. This allows the denser regions on the opposite side to pull on us without any resistance from the empty side. Astronomers call this the dipole repeller. The local void is essentially shoving the Milky Way. We are being pushed away from the emptiness and hauled toward the mass. Our invisible velocity of 1.4 million miles per hour is not just caused by what is pulling us, but by the terrifying vacancy of the voids that are actively chasing us away. This realization changes the geography of the void from a map of absence into a map of influence. We used to think that the interesting part of the universe was the matter, the 5% that we can see. But the behavior of the Botas void and the local void shows that the nothing is the primary driver of cosmic history. The voids are not failures of structure. They are the growing bubbles of the universe's future. The data shows that voids are expanding faster than the average expansion rate of the universe. Because they have less matter to slow them down with gravity, dark energy is able to inflate them at an accelerated pace. Voids are like the holes in a rising loaf of bread. As they grow, they stretch and thin out the dough of the galaxies between them. We are living on a thin filament of dough that is being systematically stretched. The Botas void is a preview of the final state of our reality, a place where the distances become so vast that the very idea of a neighbor becomes a forgotten myth. This is the deeper complication. Everywhere we look, we find that the structure of the universe is designed to separate us. The 60 galaxies trapped inside Botas are the most isolated objects in existence, evolving slowly and peacefully, but totally alone. They are cosmic fossils, pristine and unchanged because they have no neighbors to collide with, no external forces to trigger new star formation. They are essentially frozen in time. As we measure the growth of these voids, we have to confront the fact that our window on the rest of the universe is closing. We are currently in a sweet spot where the voids haven't yet become so large that they have erased the map. But the expansion is relentless. The investigation into the nothing has revealed that we are not just losing the future, we have already lost the past. Because of the way these voids grow and space expands, there are entire epochs of history that have been redshifted into total invisibility, leaving us with a redacted map of our own origins. If this kind of deep, numerical investigation into the hidden geography of our reality interests you, ensure you are subscribed. The investigation continues in the next chapter, where we will address the information paradox, the terrifying possibility that we are already looking at a universe that has been 99% erased. Chapter 8. The Information Paradox. Right now, as you sit in the quiet of your room, the universe is deleting its own history. This is not a metaphor for the passage of time, and it is not a philosophical reflection on the fleeting nature of existence. It is a physical, measurable process happening to the fabric of space itself. We have already established that the universe is overwhelmingly empty, but the data now shows a much more disturbing complication. The window through which we observe that emptiness is closing. We are living through a period of cosmic redaction. This is confirmed science measured directly by the Hubble Space Telescope and the Planck satellite. The data shows that the expansion of the universe is not just moving galaxies away from us, it is scrubbing the evidence of their existence from the sky. We are currently participating in the final act of a long-form information erasure. To understand the scale of what we are losing, you have to look at the limit of our sight. Astronomers refer to this as the surface of last scattering. To translate this technical term into plain English, it is the cosmic fog that marks the beginning of visible history. For the first 380,000 years after the Big Bang, the universe was so hot and so dense that light could not travel through it. It was a thick, opaque soup of ionized plasma. Photons, the particles of light, were constantly bumping into free electrons, unable to move more than a few inches before being scattered. If you had been there, you would have seen nothing but a blinding, featureless white glare in every direction. There were no stars, no galaxies, and no space as we understand it. Then the universe cooled just enough for electrons to pair with protons, forming the first atoms of hydrogen. This is a process called recombination. In an instant, the fog cleared. The light was suddenly free to travel across the void. Those first photons began a journey that has lasted 13.8 billion years, finally arriving at our telescopes today as a faint hiss of microwave radiation. We call this the cosmic microwave background, or the CMB. This is the absolute wall of our reality. We can see back to the moment the fog cleared, but we cannot see past it. Everything that happened in those first 380,000 years, the birth of the physical laws, the fluctuations that would eventually become galaxies, the very DNA of our universe, is locked behind that wall of light. This is where the honest uncertainty of our investigation begins. While we can use the laws of physics to model what happened behind that wall, direct observation is impossible. Multiple independent teams of scientists have confirmed that we have no way of knowing if there were structures, physical constants, or even entire lost epochs of history that existed before the CMB cleared. The expansion of the universe has already redshifted any potential signals from that era into total, permanent invisibility. To visualize this, imagine you are standing in a large library at night with a single, small flashlight. You can see the books on the shelves immediately around you. You can see the titles, the colors of the spines, and the texture of the paper. But the flashlight's batteries are dying. Every minute, the circle of light grows slightly smaller. The shelves at the edge of the room are already gone. Soon, the shelves 10 feet away will vanish. The data shows that we are the generation holding the dying flashlight. Because of the vacuum energy, the dark energy we discussed in Chapter 6, the space between us and the rest of the universe is stretching at an accelerating rate. This expansion creates a cosmic event horizon. Once a galaxy crosses that horizon, its light can never reach us again. It is not just too far away to see, it is causally disconnected from our reality. Based on current measurements, we have already lost the original map of the universe. The vast majority of the galaxies that exist in the total universe are already beyond our horizon. We are looking at a redacted document where 99% of the text has been blacked out by the expansion of space. We are left trying to reconstruct the entire story of existence from a handful of surviving sentences. This is the information paradox. As the universe gets older, it becomes harder to understand where it came from. In 1 trillion years, the redaction will be almost complete. Future civilizations living in what remains of our local galaxy cluster will look up at the night sky and see nothing. The expansion will have carried every other galaxy beyond the horizon. The cosmic microwave background will have been redshifted so far that its wavelength is longer than the galaxy itself, making it undetectable by any possible instrument. To those future observers, the universe will seem static, empty, and eternal. They will have no evidence of the Big Bang. They will have no way of knowing that trillions of other galaxies ever existed. They will look at the darkness and conclude that they are the only thing that has ever been and the only thing that will ever be. They will be trapped in a lie created by the physics of the void. This is what makes our current moment so fragile. We are the last generation of observers who can still see the evidence of our own origins. We are the only ones who can still see the CMB, still measure the expansion, and still map the cosmic web before the voids grow so large that they tear the map to pieces. We are in a cosmic sweet spot, a brief window of time where the universe is old enough to have produced life, but young enough to still be observable. But even within this sweet spot, the data suggests we are already missing something massive. In Chapter 1, we spoke about the invisible velocity, the fact that we are being hauled toward an unknown point at 1.4 million miles per hour. We can feel the gravitational tug of something gargantuan beyond our horizon, a phenomenon astronomers call dark flow. Hundreds of galaxy clusters are moving in a coherent stream toward a point we can never see. This is the law gap that most transcripts ignore. If gravity is pulling us towards something beyond the event horizon, it means there are structures out there that dwarf anything in our observable bubble. It means the emptiness we see is merely a local condition. We are like survivors on a small island feeling the tide being pulled by a continent we will never be allowed to visit. This creates a profound sense of intellectual unease. We have confirmed the existence of the void, and we have measured the rate at which it is growing. But we must also admit that our map is incomplete. We are staring at a redacted universe, trying to find the reason for the emptiness while the evidence is being systematically destroyed. This is not speculation, it is the inevitable result of the laws of thermodynamics and general relativity. The arrow of time points toward erasure. The order we see now, the galaxies, the stars, the coffee cup on your table, is a temporary pattern in a system that is trending toward a final, absolute silence. We are the eyewitnesses to the end of the age of information. We are the species that happened to arise at the exact moment when the mystery was still solvable. The investigation into why the universe is being emptied is ongoing, and we are the ones doing the measuring. But as we look into the far future, we see that the voids are not just growing, they are preparing the way for a state of perfect frozen equilibrium. A state where the emptiness is no longer a moat or a shield, but a final destination. If this kind of deep, factual investigation into the limits of human knowledge interests you, ensure you are subscribed. The investigation continues in the next chapter, where we will face the final fate of the void, the heat death of everything. The final resolution is not a fire, but a slow, rhythmic, fading into the dark. We are moving toward the final equilibrium, and the timeline is already measured. Chapter 9. The Final Equilibrium. We have spent the duration of this investigation exploring the nothing as if it were an external threat, a moat that protects us, or an expansion that erases our history. But the data shows that the emptiness is not just a condition of space, it is the inevitable destination of all matter. We are currently living through the stelliferous era, the age of stars, a brief and vibrant flicker of disequilibrium. But this era is 99.9% complete in the eyes of deep time. We are moving toward a state of perfect frozen balance, and the timeline for this transition has already been measured. This is the partial resolution of our investigation. We now know for certain that the universe is not just empty because it is big, it is becoming empty because it is cooling. This is the law of entropy. To understand entropy in plain English, think of a cup of hot coffee sitting on your kitchen table. The coffee is hot, and the room is cool. Because of this difference in temperature, energy flows. The coffee warms the air cools the coffee, and for a brief moment work can be done. Steam rises, molecules move, and heat is exchanged. But eventually the coffee and the room reach the exact same temperature. At that point, the system has reached thermal equilibrium. The energy hasn't disappeared. It is still there in the room, but it is now spread so evenly that nothing can ever happen again. No more steam will rise, no more heat will flow. The system distilled is dead. The data shows that the universe is that cup of coffee, and it is currently cooling toward the temperature of the room. The first stage of this cooling begins roughly 100 trillion years from now. This is the end of the stelliferous era. For billions of years, the cosmic misers, the small, dim red dwarf stars, have been sipping their hydrogen fuel with extreme efficiency. But eventually, even they will exhaust their supply. One by one, the last lights of the universe will flicker and fade. The night sky, which once held 2 trillion galaxies, will become a vault of absolute black. This marks the beginning of the degenerate era. This technical term refers to the state of the matter left behind: white dwarfs, neutron stars, and black holes. In this era, the universe is no longer a place of nuclear fire. It is a planetary graveyard. Imagine your house after the fireplace has gone out. The logs have turned to white ash, but if you hold your hand near them, you can still feel a faint, dying warmth radiating from the embers. White dwarfs are those embers. They do not burn fuel, they simply radiate the leftover heat of their former lives into the vacuum. This is confirmed science, and we have measured the cooling rates of white dwarfs and found that over time, scales of 10 to the 15th power years, 10 quadrillion years, even these embers will cool to near absolute zero. They will become black dwarfs, cold, dark spheres of crystallized carbon and oxygen drifting through an expanding void. During this time, a process called gravitational slingshotting will occur. When 2 stellar remnants pass near each other, they exchange momentum. One is slowed down while the other is accelerated. The data shows that over trillions of years, 90% of all stars and planets will be ejected from their galaxies, flung out into the intergalactic void to drift alone forever. The remaining 10% will fall into the centers of their galaxies, where they will be consumed by the only things left with any power, the supermassive black holes. By 10 to the power of 30 years, the galaxies themselves will have evaporated. The scaffolding of ghosts we discussed in Chapter 5 will have done its job, and the matter will have either been exiled or swallowed. This begins the black hole era. For a long time, we believed that black holes were eternal, that they were the final trash cans of the universe, where information went to die. But in 1974, Stephen Hawking discovered a complication that changed everything. He discovered Hawking radiation. To understand this in plain English, we have to look back at the nothing of the vacuum. As we established, the vacuum is not empty. It is a seething ocean of virtual particles that pop into existence in pairs and immediately annihilate each other. But Hawking realized that if this happens at the very edge of a black hole, the event horizon, one particle might fall in while the other escapes. Because the escaping particle has energy and energy is equivalent to mass, the black hole must lose a tiny bit of its weight to pay for that particle's escape. The black hole is slowly leaking. It is evaporating. This process is staggeringly slow. A black hole with the mass of our Sun would take 10 to the power of 67 years to evaporate. But the supermassive black holes at the centers of galaxies, the titans that are currently hauling us through the dark, will take much longer. 10 to the 100th power years. That is a 1 followed by 100 zeros. It is a number so large that there is no domestic analogy for it. The entire history of the universe from the Big Bang until this moment is less than a single microscopic heartbeat compared to the lifespan of a supermassive black hole. But the data is clear. Even they are not permanent. Over incomprehensible eons, the black holes will steadily lose mass. As they get smaller, they get hotter. In their final second of existence, they will release a flash of energy equivalent to billions of nuclear bombs, a final, desperate scream of light in a universe that has been dark for trillions of years. And then they will be gone, This brings us to the honest uncertainty of the final resolution. If the theories of grand unification are correct, matter itself may not be stable. This is the hypothesis of proton decay. It suggests that even the atoms in your body, the protons that form the nucleus, have an expiration date. The measured lower bound for this decay is 10 to the 34th power years, but it could be much longer. If protons decay, then the black dwarfs, the cold planets, and the dust will eventually dissolve. They will not explode. They will simply evaporate into a thin soup of electrons, positrons, and neutrinos. Matter, in the conventional sense, will cease to exist. The something that makes up 5% of our universe will have finally been digested by the nothing. This is the state of heat death. It is important to understand that heat death is not a fire. It is not a big rip or a violent ending. It is a state of maximum entropy. The universe will reach a temperature of nearly absolute zero. The expansion of space, driven by the constant density of dark energy, will have pushed every particle so far apart that no two particles will ever be able to see each other again. Each electron will exist in its own private, observable universe, a sphere of billions of light-years containing absolutely nothing else. This is the final equilibrium. It is a state where the universe is perfectly balanced. There are no more gradients, there are no more differences in temperature, there is no more work that can be done. Time itself will become a meaningless concept, because time is only measured by change, and in a state of heat death, nothing will ever change again. The universe will sit in this frozen silence for the rest of eternity. When you look at this timeline, you realize that the era of structure, the era of stars, galaxies, and consciousness is an infinitesimally brief flicker at the very beginning of the story. Trillions of years from now, the universe will spend the vast majority of its existence as a cold, empty vacuum. Fullness is the anomaly, emptiness is the rule. We are living in the morning of the universe, a brief moment of disequilibrium before the long, permanent night begins. This realization brings a specific kind of existential weight. It suggests that the universe is empty for a reason, because emptiness is its fundamental preferred state. We are the defect in the system, a temporary concentration of energy that is slowly being smoothed out by the laws of thermodynamics. But as we look at the rarity of this moment, we have to ask one final question. If we are just a brief spark in an ocean of void, why did the spark happen at all? Why is the universe empty enough for us to exist right now instead of being too empty or too full? The investigation concludes with a human-scale reflection on the rarity of the observer. The universe is empty for a reason, and that reason is the only reason you are here to ask the question. If this kind of deep investigation into the final fate of our reality interests you, ensure you are subscribed. The final beat, the meaning of the scale, is next. Chapter 10. The rarity of the observer. Right now, as you sit in the silence of your room, you are participating in the most improbable event in the history of the universe. Your heart is beating with a steady, rhythmic thrum, a localized concentration of energy and complexity that defies the overwhelming trend of the cosmos. You are breathing in atoms of oxygen and nitrogen that were once forged in the nuclear furnaces of stars and scattered across the dark by the violence of supernovae. This is not a poetic observation. It is a physical reality that you are currently inhabiting. You are a collection of something in a universe that, as we have measured, is almost entirely nothing. You feel solid, stable, and permanent. But this is the final sensory illusion we must peel away. As we have seen, the data shows that you are a participant in a cosmic accident. You are currently existing in a brief, fragile window of time between the blinding glare of the Big Bang and the absolute frozen silence of the heat death. And the very thing that makes this moment so unsettling, the terrifying emptiness that surrounds us, is the exact reason you are here to wonder about it. The emptiness of the universe is not a bug, it is a feature. This is what the data reveals when we look at the precise density of the cosmos. Imagine, for a moment, that the universe was not empty. Imagine if the density fluctuations in the first seconds of history had been just 1 part in 1,000 instead of 1 part in 100,000. This is a measured discrepancy that scientists have modeled using supercomputer simulations. If the universe had been even slightly more crowded, gravity would have been too efficient. Instead of gas clumping into stars and elegant spiral galaxies, matter would have collapsed violently and immediately. The universe would have become a graveyard of black holes before the first atom of carbon could ever form. Alternatively, if the universe were only slightly emptier than it is now, gravity would have been too weak to overcome the expansion. Matter would have drifted apart as a thin, uniform gas of hydrogen and helium, never clumping, never igniting. There would be no stars to light the dark, no planets to provide a floor for life, and no consciousness to measure the distances. This is what the data says. We live in a universe that is exactly this empty because it is the only level of emptiness compatible with your existence. This is a form of selection bias known as the anthropic principle. We observe the universe to be this vast and hollow because if it were any fuller, we wouldn't be here to observe it. To bring this home to a human scale, consider the moat we discussed in the earlier chapters. We have measured the distance from our Sun to Proxima Centauri as roughly 25 trillion miles, the 19-mile gap between 2 grains of sand. This distance feels like a terrifying isolation, a lonely wilderness that separates us from our neighbors. But the reality is that this 19-mile gap is your primary survival mechanism. If stars were packed together like commuters on a morning train, the radiation alone would be lethal. Every few thousand years, a neighboring sun would drift close enough to tug on the Earth, pulling us out of our stable orbit and flinging us into the frozen dark or plunging us into the solar fire. Every few million years, a nearby supernova would strip away our atmosphere, sterilizing the planet in a flash of gamma rays. Life on Earth required 4 billion years of uninterrupted peace to evolve from simple chemistry into the consciousness you are using to process these words. You were only given those 4 billion years because the universe is so beautifully, gloriously empty. The void is not your enemy, it is your shield. It is the buffer zone that keeps cosmic violence at a safe distance. We are tucked away in a quiet suburban stretch of the Milky Way, where the neighbors are miles apart, and the noise of the galactic center is a distant, harmless hum. And this brings us to the inside the phenomenon trigger. You are not just a spectator of this emptiness, you are made of it. As we established in our hollow body correlation, the same math that governs the stars governs your own atoms. If the universe was shrunk to the size of the Earth, all the stars would fit inside a single proton. But as we have confirmed through quantum field theory, the proton itself is mostly empty space. If you were to remove the vacuum from between your atoms, you would become so small that you would be invisible to any microscope on Earth. You are a localized island of complexity, a temporary pattern of matter held together by invisible forces, floating in an ocean of void. And this is the intellectual satisfaction we seek, the realization that solidity is a sensory deception. We feel heavy and substantial because of the electromagnetic repulsion between atoms, but in terms of mass and volume, we are almost entirely composed of the same nothing that fills the gaps between the galaxies. You are not a solid object moving through an empty universe. You are the void itself, temporarily organized into a form that can think, feel, and ask why. And why is the most important question of all. As we look at the timeline of the universe, we see that we are living in a Goldilocks era. Trillions of years from now, the expansion will have carried every other galaxy beyond the horizon. Our descendants will live in a universe that truly is empty, a single galaxy surrounded by an infinite, reachable dark. They will look at the sky and see no evidence of the Big Bang, no cosmic web, and no other galaxies. They will have no way of knowing that they were ever part of a larger story. But you can see it. You are living in the one era where the universe is both full enough to produce observers and empty enough to be transparent. You can see the light from 13 billion years ago. You can measure the expansion. You can map the Bhuta's void. You are the eyewitness of the cosmos, the rare and fragile lens through which the universe is finally admiring its own beauty and trembling at its own fury. This is not speculation. It is the measured reality of our place in time. We are islands of complexity in an ocean of void. And while that might sound lonely, there is a profound weight to that rarity. Because the universe is so overwhelmingly empty, the parts that do contain something become infinitely more precious. If the universe were a solid block of matter, there would be no room for change. If it were a crowded ballroom of stars, there would be no room for peace. The universe is empty for a reason. It had to give us the space to exist. It had to provide a stage large enough for the drama of life to play out without being crushed by the weight of the scenery. We are the anomaly that refuses to die. We are a small, wet, illuminated rock that against all the crushing forces of entropy and expansion managed to produce a mind, and that mind is currently looking back at the void and realizing that the silence isn't a threat, it's a gift. The universe is empty so that you could have a room to sit in. It is vast so that you could have the time to evolve. It is silent so that you could hear your own thoughts. As you prepare to turn off your screen and return to the stillness of your night, remember that you are not insignificant. You are the universe's way of knowing itself. You are the rare, brilliant error in an infinite abyss that finally found a way to reflect on the dark. We live in a house made of invisible materials, protected by a moat of light years, and we are the last generation that can still see the whole map. The investigation into the great silence is ongoing, and you are the species doing the measuring. The universe is empty for a reason, and that reason is you. The investigation into the void is never truly over, but for tonight, the map is clear. If you find this kind of deep, human-scale reflection on the mechanics of our reality satisfying, ensure you are subscribed. The next investigation begins soon. For now, the darkness is quiet. The coffee is still. And you are here. And in a universe this empty, that is the most interesting thing we know.